Hello, now after we've inspected regions and availability zones, let's have a look at some very important features, namely VPCs and subnets. We'll see what these are and also why you can't do without them, especially with regards to security. To run anything securely in AWS, you need a VPC, or in other words, a virtual private cloud. Think of a VPC as your private customizable data center inside AWS. It's the foundation for all your cloud networking. Now, a VPC provides a logically isolated section of the AWS cloud where you can launch AWS resources, giving you more control over your network configuration and security. Now, to be precise, a VPC is a virtual network where you can launch, connect, and secure all your AWS resources. Each AWS account starts with the default VPC, but you can create more if you like, and you usually do. So, you would create a production VPC, a development VPC, a VPC only for web service or for internal usage only, and another one for external connections, etc. So you can have many VPCs if you like. Now, such a VPC is isolated from others, even from other VPCs that you own. This isolation gives you strict control over which resources can communicate and how. Now, for some key concepts, when you create a VPC, you choose something which is called a CIDR block, which is a big pool of private IP addresses like 10.0.0.0/16, and every resource in the VPC, like an EC2 instance or database, gets an address from this range. Now, to be able to segment this CIDR block, you could create subnets that each get a part of this block. So, for example, from 10.0.0.0/16, we could say we're going to create a subnet that has 10.0.1.0.24, 10.0.2.0/24, etc. So we can create subnets that fall within that CIDR block range. And next to that, we can make a distinction between public subnets and private subnets. Now, public subnets have resources like load balancers and web servers that can access the internet directly, usually through an internet gateway, and are also accessible from the internet. Now, private subnets used for sensitive resources like databases or internal application servers aren't exposed directly to the internet and also not directly accessible from the internet. They might talk to the outside world using a NAT gateway, but outside systems can't reach them directly ever. Now, here comes the relationship with availability zones. Each subnet lives in a single availability zone, but you can have multiple subnets in the same availability zone. And having different subnets in different availability zones will give you the possibility to create fault-tolerant systems, like you run your web servers in the first availability zone, but also in the second availability zone, put a load balancer in front of it, and you have a highly available environment. If one availability zone would fail completely, the other one would still have the web servers up and running. Now, for security, VPCs use security groups and network access control lists for a fine-grained firewall-like control over what traffic is allowed in and what traffic is allowed out. Now, since this is a high-level overview, it might suffice to say that network access control lists, or NACLs, are configured at the subnet boundary, where security groups are for individual resources like virtual machines inside the subnets. Anyway, you can isolate your workloads from others. And another advantage of subnetting is that you can scale your services by creating new subnets without disturbing the existing ones. So in summary, a VPC is a private space in AWS like your own slice in the cloud. Subnets carve up your VPC for organization, security, and resiliency. And you can use public subnets for internet-facing resources, private subnets for everything that is sensitive. Now, next we'll see how multiple VPCs or even different AWS regions can connect to each other using peering and transit gateways.